recorded pressures of 200 pounds per square inch, 16 feet from the weapon. The third and last Betty weapon tested was burned 3 different times. This is after the first burn, in which the weapon burned freely for 5 minutes before water was applied. The gasoline continued to burn for an additional 15 minutes. Damage was limited to destruction of the lightweight aluminum tail cone and to scorching and charring of the exposed portions of the hydrostatic switches and timers mounted on the aft bulkhead. This is that same weapon after the second fire. Water was applied after 6 minutes of free burn. The weapon survived without visual evidence of damage to the high explosive material in the warhead, even though a large hole was burned in the aft aluminum bulkhead. This weapon was burned for a third and last time, and no water was applied. A 5-knot wind prevailed during most of the test. Visible burning of the high explosive material was observed at 11 minutes. At 12 minutes, 11 seconds, the warhead detonated low order. Unburned HE material was scattered to the rear of the test stand, and the weapon's pressure hull was propelled forward, approximately 100 feet. The tubuloid capsule was recovered intact near the place where the pressure hull came to rest. No measurable air contamination was present. Of the 3 alias Betty weapons tested, 2 detonated high order and 1 detonated low order. Cooling water, when applied as late as 6 minutes after a weapon was engulfed in flames, was effective in preventing detonation. Without the application of cooling water, an alias Betty weapon will probably detonate. The last atomic weapon to be subjected to the fire tests was Lulu, a depth bomb employing the Mark 34 warhead. This test is typical of 6 different fire tests involving 6 different Lulu weapons. No detonation occurred in any of the Lulu tests. Damage was confined to melting of the tail section and to ejection of the nose cap and the forward half of the warhead case caused by pressure buildup inside the warhead compartment. Water was effective in preventing destruction of the weapon when applied as late as 8 minutes 30 seconds. And was not effective when applied at 10 minutes. These fire tests, conducted on 3 different naval atomic weapons, were limited in number. For this reason, the information obtained cannot be considered conclusive. Bearing this in mind while examining the test data on these charts, an analysis of the results obtained indicates that the Mark 7 in a bore weapon, when involved in a fire accident, will burn and occasionally will detonate low order. Note on this chart that the high explosive material in the Bore 1 weapon, containing a live warhead and a dummy motor, ignited at 1 minute 20 seconds. No water was applied and no detonation occurred. With Bore 3, cooling water was effective in preventing ignition when applied at 75 seconds. An entirely different result was obtained when the Mark 7 warhead was tested in the depth bomb alias Betty. In this case, the confining effect of the steel pressure hull caused the warhead to detonate. When cooling water was applied to Betty 2 at 7 minutes, sufficient heat had already been transferred into the weapon to cause the warhead to detonate at approximately 15 minutes. In spite of the fact that cooling water had sprayed onto the weapon continuously for 8 minutes. Betty 3 was saved when cooling water was applied at 6 minutes. The depth bomb Lulu appears to be the least hazardous of the 3 weapons tested. None of these weapons detonated. When cooling water was applied to Lulu 4 at 7 minutes 35 seconds, the weapon was saved. Lulu 6 was saved when cooling water was applied at 8 minutes 30 seconds. Application of cooling water to Lulu 5 at 10 minutes was too late. The high explosive ignited and burned. Results of these naval atomic weapons vulnerability tests indicate that the metallic radioactive materials in either the Mark 7 or Mark 34 warhead do not present an undue hazard to firefighting personnel. Standard radiological monitoring and decontamination procedures are adequate to cope with this problem. However, the Mark 34 and other gas-boosted warheads contain a radioactive gas that is extremely toxic. For this reason, firefighting and rescue personnel should avoid breathing any fumes emanating directly from the burning weapon. The 3 points to remember when an atomic weapon is involved in a fire accident are: 1. The possibility of a nuclear reaction is extremely remote. 2. Standard clothing worn by firefighting personnel is adequate protection from radioactive contamination. And finally, detonation of the high explosives can be prevented by timely application of cooling water.